we are going to look at some of the tests that are already present as a part of the Slither repo. So you can see that these tests have been built for developers like us to understand what are the probable issues that could come up in our contract and how can we, account for those. There are a bunch of tests, a lot of them you can see, and you can peruse this repo at your own sort of, timeline. But in this tutorial, what we are going to do is we are going to look at a specific test called arbitrary send each within detectors, right? Now, the first step for you would be to clone this particular GitHub repo in order to get access to these tests. So what I have done is I have already cloned this repo with me. So it would be easier for me to, quickly show you. So I have cloned this repo called Slither, which is the repo present over here. Within Slither, you can find that there are tests. So you go inside tests, and within tests, we are going to look at a particular type of test called detectors, right? So as the name suggests, these are detecting some faults as you are writing your Solidity code. Within detectors, there are again a bunch of tests that are available. We don't want to go through all of them, of course. We don't have the time for it. But we are going to look at a particular test called arbitrary send each, right? So when you click on arbitrary send each, you will find that this particular test is there for multiple versions of Solidity. We are going to go to the latest one that is available in the repo, that is 0.7.6. And the contract that we will be looking at is the arbitrary underscore send underscore each dot so, right? So there are some legitimate calls happening within, this. Okay, let's quickly take a look at this contract on VS Code so we can, understand what is this piece of code that we are going to be dealing with. So I'm going to view whether this is arbitrary send each. Second, gonna see the name. Yeah, this one, and then we are going to look at the soul contract. So here, let's see what is happening very quickly. We have a contract called test. It has an payable address called destination. There is a mapping balances, which is between address and event, balance of each address. There is a constructor called balances. So I know that in 8 version 0.8.x onwards, we don't have this visibility of constructor that we need to mention, but in 0.7.6, we need to have it. So here, the initial balance of the message.sender, that is whoever is calling the constructor, whoever is deploying the contract, is set to 0. There is a function called direct, which is using the send call, right, for message.sender, that is whoever calls this. And then they are transferring the entire balance that is available in this contract to this particular message.sender. This is what is happening in this call. Then there is an init function where the destination is assigned to as message.sender, right? That is whoever is calling the init, the destination variable will be assigned to that particular user. Then there is an indirect call where we are using the destination as the address and we are using the dot send to send the balance of this particular contract to the destination address. There is a repay function, which is payable, where we can the message dot value that has been sent to this particular function to the message dot sender. Then there is a withdraw function where we are getting the balance of the message dot sender and we are sending this particular value to the message dot sender. There is a buy function which is again payable. So we have a message dot value that's been sent to this function. Then we are sort of simulating a buy of tokens basically. And then we are not spending any tokens here. So value sent remaining is value sent minus value spent. And the message dot sender, whoever is calling them, we are sending the remaining amount to them, right? So here we can simulate a buy. When we change this value, it's like, we are simulating some buy. That is, this contract is sort of buying some of these tokens. So, okay. Now, This is the contract that we are going to be working with. I already have this contract, so I'm going to say ready, send reads, right? And 0.7.6. Now, don't forget to change your Solcy version to 0.7.6. I already have it installed, I believe. So I'm going to try to just switch it directly. Yeah. So I have used this use and switch the version directly. However, if you don't have it installed, please read these instructions and install them. So once you're done with the setup, let us run, Slither on the source file. Okay, I'm in the right location. I'm going to clear things. So, okay. Now we can see what I was talking about earlier. That is the various colors of warning, of course. And then also, let's see what it says that. Okay. So here we have some standard warnings, that is SPDX, license identifier, unlicensed. So earlier for 0.7.6, we don't really need this, but also this contract basically, does not have anything. So let's add this pragma solidity 0.7.6, right? And then run this again. Okay. So now let's again go to the top. So this time, this did not give us mm, the warning about the version, right? Because 0.7.6, according to the standards, is actually a compatible version, recommended version. Now, the first thing it tells us is about visibility for constructor, right? So since we don't need visibility, it's not it's not mandatory, so it's just a warning. So we can actually just remove this, right? Now, the second is there's a warning that failure condition of send is ignored, right? Consider using transfer instead. We can see multiple places that this send is having warnings, right? So, as we saw in the best practices, that we should actually be using the call function, right? It's not even send or transfer. Call is the most safest option to use. So we can see, okay, we understand these warnings. Now let's start taking a look at the very red warnings, right? Let's see what's happening. Now we try to test direct. Sorry, I keep pressing arbitrary thing. So when it tested the function direct, this sends ETH to arbitrary user, right? This direct function. So let's take a look at this. Okay. So this sends to arbitrary user. That is, whichever message the sender is calling, it will just send to that person. Now, here, what are the dangerous calls? Message.sender.send, right? Sends ETH to arbitrary user, right? So basically, it's just sending, like, what it's asking is it your intention to send the entire balance to anyone? Like any arbitrary user who just calls this? Basically, now this is so open to exploit that anybody who calls this function will just get the balance into their account, right? So this obviously an exploit can be done from here. And then in test.indirect, the dangerous call is we are sending to the destination, right? So here it also gives you a reference as to when you're sending ETH to any destination, what are some of the things that you should keep in mind, right? Sending Ether functions and send Ether to arbitrary destination, right? So there is a documentation around this. And what does it mean? What does Slither mean when it says this? It says that the severity is very high, the confidence is high, right? There is a compiler bug. Now, the exploit scenario is that you can just set this destination and Bob calls set destination and withdraw. As a result, he withdraws the contract balance. So the same thing is happening here. That is, anyone can call this init and set the destination to themselves and then call the indirect function to send it to them, right? So this is a vulnerability, and ensure that an arbitrary user cannot withdraw unauthorized funds. So there is no authorization here, right? So this is a huge red flag that we can see in red. Now there are also some yellow flags and green flags, which we will explore in the next video.